This video will be on how to replace the most often failing capacitors in the fan in these Wei-Ya P2040 switch mode arcade power supplies. These were the ones with the 5 volt, 12 volt, 24 volt and 48 volt rails with a current limit of 6 amps and a total power limit of 280 watts. They're most commonly used in most crane machines available on the market. The issues that cause these to fail are poor capacitor quality, just the original ones aren't that great, failing fans, and the original capacitors don't handle heat that well, so as soon as they lack any amount of cooling they fail and start to cause faults. Because the underlying issue is mainly heat, it pays to keep the ventilation slots on your machines clean and clear, but also replace power supplies as soon as the fans start to fail, as this greatly increases the likelihood of a successful repair. Parts that you're going to need to do this repair are, you're going to need a 2-wire 80mm fan. This one, it's 80 by 80 by 25, it's the same as the original one. Then you're going to need a 63 volt 47 microfarad capacitor, a 10 volt 1000 microfarad, two 25 volt 1000 microfarad, an 80 volt 1000 microfarad, a 35 volt 2200 microfarad, a 25 volt 2200 microfarad, a 10 volt 3300 microfarad, and a 10 volt 2200 microfarad. There are other capacitors in the power supply, but these are all the ones that we're going to be replacing. The other ones typically don't tend to fail. Here are some of the tools that you need for doing this repair. You need a decent quality solder sucker. The cheap $1 or $2 ones on eBay just don't cut it. You need some pliers. You need a fair amount of 6040 leaded solder. Don't use lead free. You need a temperature controlled soldering iron. You need some cutters to cut the leads off the end of the capacitors after you put them in the board. And you're going to need a Phillips head screwdriver. Step 1 is to take the casing off. There's going to be a bunch of screws that you need to undo. Main ones are these 4 ones on the top. There's the daughter board here, which screws on with these 2 screws on the back. And you need to take out this switch here with those 2 screws, and you need to take the fan out, as we'll be replacing that as well with these 4 screws here. The exterior screws have 4 different categories. There's these larger coarse thread screws, there's these small short fine thread screws, there's these small longer fine thread screws, and there's these tapered head coarse thread small screws. Each of these groups of screws, these ones are for the fan, these ones are for the small daughter board on the back, these slightly longer ones, those are for the voltage selector switch, and these ones are the 4 that go on the top of the case. Now that we've got all the screws out of the casing, you can lift the top cover off and just place it aside. Now that we've got the casing off, there's 4 more screws that you're going to want to get. So there's one there, one there, one there, and one there. These screws are different again. They're similar to the ones for the top of the case, but they don't have the tapered head. So all of the screws are different and it's really hard to mix them up. Once you're into the casing, you're going to need to undo these connectors for the 24 volt and 48 volt rails. You're going to want to undo these plugs here off the back of the mains power switch. So that's your main input to the board. Once those are out, slide this out of the slot here, slide the fan out of there, and then sometimes these loops of wire in here that go from the main power input to the main power switch, you just need to push them out the way, lift up your board, and just work it around past this loop of cable. And out the board comes. So now you've got your board out. So you're going to be replacing 9 capacitors. So it's these 3 through here, these 3 in here, and these other 3 on this other side. So the solder pads that you're going to want to desolder is these two here. Those ones are for the fan. These two here. This one and this one. That one and that one. This one and this one. This one and this one. That one and that one. These two, and these two between these traces that run along here. You can tell because this one, it's got two positions, so it makes it easy to find the right one. Because these boards are RoHS compliant, it means that they use lead-free solder. Now, lead-free solder melts at a much higher temperature to leaded solder. I typically heat my soldering iron up to around about 375 degrees Celsius, or about 725 Fahrenheit. Sometimes if I'm having issues with one, I'll bump it up to say about 400 Celsius and about 750 Fahrenheit. So the first ones that I always do are the fan wires. Those just come out the back like that. This fan is well and truly stuck, so they can go in the bin. So now that I've fed some leaded solder in, push down the plunger on your solder sucker, or desoldering pump, however you want to call it. Heat up the joint, quickly move it in, push the button, and it sucks all the solder out of that joint. So typically what I do I just go around all the pads and feed in some leaded solder, because it makes it much easier to work with. Now that most of that's done, just work your way around, pulling out the capacitors. And some of them, they get a little bit stuck, so while pulling on them, just give them a little bit of heat, and then they pop out. Yeah, so now all the old ones are out. These slots are free. These ones, these ones, these ones, these ones, those ones, those ones, those ones, and those ones for the fan. Now you get to putting in the new capacitors. So the new ones typically I start with smallest value first, so these three along here. And so each capacitor has a long leg and a short leg. On these boards, the positive side is marked with the striping. Now on each capacitor there's a stripe down the side of each one, and that marks the negative side. So the negative side is the short side, positive side is the long side. So where there's the striping on the board, that's the side that the long hole goes into. And then the short leg goes into the other one. Now on these boards, all of the negative stripes should be facing either that way or that way. There should be none facing inwards and none facing this way. Typically I do the first couple of them before soldering them in. It's fairly simple. Just get your soldering iron, go across both the lead and the board at the same time. Never apply solder to there and then transfer it on, because the flux is already burnt off and then you have a terrible solder joint in there. After you've soldered the leads in, this is my sort of small bin. It's glass because the solder doesn't stick to the inside of it. You just get your cutters and just cut away the excess. And just repeat this process for all of them. Don't forget the little one that tucks down inside there. So now, because the fan is the only one that doesn't need trimming, so trim off all the other ones. So for your fan one, you want to make sure that your solder pad is nice and clean and open. Make sure those little holes in there, that there's room for the new wires to run through. So you get your new fan, make sure you got about 5 or 6 inches. Cut the plug off there, because we don't need that, that can go in the bin, or if you got anything else that needs those plugs you can use them for that. Because the holes are slightly spaced apart, I'll split those. There's a bit of a gap in between, and then strip off about 2mm. So it should look like that. Now on this side over here, towards where all the capacitors that you just put in, that's positive, and towards the middle of the board, that's negative. Just run that down through there, being careful not to fray out the leads. Sometimes this can be a little bit awkward. You just have to get it in the right place that it stays in place. Also avoid knocking the lead back through. So now that's soldered in there. That's this board done and ready to go back in. Helps to keep a vacuum cleaner handy to clean up the workspace. Now we've got our casing, this piece here with the bit that folds up, that always goes at the back. Get your new power supply board, or your freshly repaired one. Bring it in this way. It helps to go in from the opposite side to where the mains input is. Now it's sitting down there on the screw holes. The way this goes in is with this piece of the fan that has the wire running through it on this side. So just let that sit down in there. Typically the first thing that I put back in first is the fan. Because they differ. So that's the fan in. This voltage selector switch, this piece here, you have to run it between these two loops for the mains input and put it up against here. So it's typically set up so that when the switch is that way and it says 230, the switch is on this side. Use the longer fine screws. Go from and either one should be on the far end. If you don't have it on the far end and you tighten it up, then the other one won't go in. Now move over to the 5-volt regulator daughter board. These are the short screws, short rounded head, fine thread. The next thing that you need to do is the ground. So the ground originally went over here, but because we've got these new capacitors in the way and these are physically larger, it won't actually go over here without getting in the way of the casing. So the other way to do it, which is actually a better way, is to use this ground here. So this is the same ground as the mains chassis ground. So you just undo the screw, run it behind the other negative wires. Sometimes the pliers can help here. Grab it through there and put the screw through both the black negative wire and the green mains earth wire. So now that's all done. So now the last couple of steps is you need to put these screws in. So these are the ones for the board. I always put them in a couple of turns until all 4 of them are in, and then screw them down, because otherwise the board can be misaligned. Don't forget to put this grommet in, the side with the loop goes on the inside. It goes in that slot there, and your wires through, and it goes over. Last thing to remember, you need to hook these up. Done that a few times. It's a real pain when you have to open the thing back up again to plug those in. Make sure you do it with the 24 volt and 48 volt ones as well. Make sure everything's good, everything's out the way. This little tab here has a bit of a tendency to try and poke out when you put the cover on. Just get your finger under there and just push it in. So now the case is back on. It's just these coarse thread tapered head screws. Put those back into the case. Yourself a power cable, plug it in, now that you've got a working power supply, grab yourself a voltmeter, put it on volts DC, put your negative into any one of these center pins, and then go to each of the 4 voltage rails. 55, so that's 48. 26, it's 24, 13, so it's 12, 5, so it's 5. So all 4 voltage rails are working just fine. Typically I find the 12 volt, 24 volt and 48 volt voltage rails, they tend to be a bit higher than what they say, but I've found that all of them do that and that's perfectly normal. It's really, the 5 volt one is what powers all of your microcontrollers and things, and so that's what's important to have a stable voltage on. If this video helped you, leave a like. If you want to see more like this, subscribe. I plan on doing more in the future. And if you got any questions, leave those down in the comments. Thanks for watching.